Hey there, you're in the lab with your mate JJ. Today is Maxitronix 30in1 day. A silly job title for today is the Phase Farer. Today I'm the Phase Farer, and this is our Maxitronix 30in1 project lab. We did project 1 last week. Today we were going to do project 2, but I went down a rabbit hole following up on project 1. A viewer, Jacques on YouTube, sent in a proposed modification for the project 1. Of course, when we did the project 1 last week, we couldn't get it oscillating properly, but Jason has suggested a pretty simple modification which makes the oscillations work. So instead of having project 2 today, I thought I'd just run through Jason's notes, and we have a look at, I spent some time documenting it on the wiki so that all of the information's together. He linked through to a number of schematics that were in like this e-viewer thing, and I couldn't get the page number linking correctly, so I've just taken some screenshots and put it all in my wiki so you can see the whole thing on the wiki. I'll link through to the wiki from the show notes. So definitely click through and check that out. There's 4 circuits are referenced, and his own circuit, you can click through to view it interactively in the Circuit.js simulator, or you can just have a look at the screenshot that I took, which includes the schematic. We do actually bring that schematic over to the project lab itself, and we implement it, and it works. So that's what today's video is going to be. It's going to be going through the notes from Jacques. Next week we'll pick up where we left off on project number 2. So today is a little digression on the first project, so we're just following up on that. So let me bring you over to the computer, and we'll start going through the notes.
Here on the computer, and this is the ITL wiki, which is at inthelabwithjj.com/wiki. We keep our projects here. Today we'll be working through the Maxitronix 30in1. Before we work on the project for today, this is the project that we did last week, and the video is over here. So let's jump over to YouTube, where we'll find the video we did last week, and particularly of interest is the comment that I received here from JT Jacques. So he said, nice demonstration. I have the Tandy/Radio Shack version of this kit. It's annoying that the circuit does not operate as expected, especially as it's the first circuit. I've proposed a very minor revision that allows you to control the pitch with the key and to simulate a siren as described in the manual. Lots more detail in the video description, including a link to the simulation. And then he gives us a link here to his own video. So let's open that up. Now I will link you to this video in the show notes. So please, by all means, click through and check it out. But he's added a whole lot of detail in here. So this video shows a Circuit.js simulation of a minor change to Project 1 from the Tandy Radio Shack Science Fair 30 in 1 Electronics Project Lab, also sold as the Maxitronix 30in1. It's the Science Fair 30in1. There you go. That allows the circuit to operate as advertised in the project description, allowing the tone to be adjusted by pressing and releasing the key. So I'm really impressed that this guy knew how to do that. It's really great. So Project 1 description and Project 1 schematic to the Radio Shack catalogs. Fascinating. This ability to raise and lower the tone by completing and breaking the switch path is also described in this essentially identical circuit from the 60in1 kit, which uses a magnetic reed switch and magnet in place of the key. Oh, there you go. This is the electronic siren. I don't know what 28256 means. Okay, so there's a link there. Equally, while there are significant changes to the component values due to the increased operating voltage, a similar circuit is also described in the later 60in1 kit, 28261. Again, the introduction details the expected tone adjustment characteristics of the circuit. This description also includes some further detail regarding how the first left transistor and capacitor act to control the second transistor, which then influences the resulting oscillation frequency. And then he's got a link here to 28261. Okay, so that's a bit confusing. I'll click through on all these links in just a minute. To allow the tone to change when the key is pressed and released, as described in the manual, I have placed the 470k resistor in parallel with the 10 UF capacitor. This allows the capacitor to discharge when the key is released and slowly turns off the transistor. Without a suitable path through which to discharge, the capacitor is able to maintain the required charge to keep the first transistor in the active region. I have replaced the 470k resistor that we have now repurposed with the 100k resistor. This shortens the charge time of the 10 UF capacitor. This substitution and the expected effect is listed as a suggested extension in the 60in1 project manual linked above. You can try the simulation yourself here. The simulation stores only the last 10 seconds of audio on a rolling basis, and no audio is played during the simulation run. To play the simulated outpush, you must press the play audio button. Note that the circuit starts in the off state until the 10 microfarad capacitor is charged via the key and 100k resistor. Once released, the simulated circuit falls into a state of self-oscillation indefinitely. With my physical 30in1 kit, pressing the key allows the capacitor to fully discharge and the tone to cease. If desired, correct switch-off characteristics can be replicated in the simulated circuit by adding the 680 ohm resistor, also available in the Project Lab kit, between the base of the transistor and the positive terminal of the 10 microfarad capacitor. For more information about the original circuit, see the video about this project from In the Lab with JJ intro project. There we go. So he's linked back to me down the bottom there, and his name is Jacques. Thanks, Jason. So, I'm going to click like on this. I think I probably already clicked like on this. I have to sign in to like. I think I probably liked it. That's probably me who's clicked like there. Should I sign in? No, I don't need to sign in. So let's click through on all of the links. So we go 1, 2, 3, 4, 5. So okay, this is fausted.com. This is Radio Shack catalogs. Okay. Um, I'm just going to pause the video for a minute, and I'm going to go and tidy up the links. You don't need to see me doing that. Alright, so I've been organizing things, and I've got our link to our project here. And I made my notes about KiCad, which is all well and good, or KiCad. Then I added this note for discussion, and I added feedback from Jacques. Our mate Jacques sent in a modification for our circuit, the Science Fair 30in1 Electronic Projects Lab Experiment Circuit 1 Fix in Circuit JS simulation. So the Science Fair 30in1 Electronic Lab is basically the same as our Maxitronix 30in1, just branded differently, but the content's the same. And his notes follow. So I took a screen grab of the schematic from Circuit JS simulation, which is linked below. This is it. The 470k resistor that was here has come down here to discharge the 10 microfarad capacitor, and the 100k has gone in place of the 470k, just because there needed to be something up there, and 100k was good enough. So we're going to make this circuit together on the board in the booth, and we'll see if we can get that tone oscillating correctly. So this capacitor should be discharged through this resistor, so the key should actually cause an oscillation, which it's not at the moment. So the video shows a circuit JS simulation. So we went through all this before, but since then I've copied in the bits and pieces. So the instructions are here. I scanned that in. The schematic is here. I scanned that in. Now he compares two versions of the circuit called Project 28, the electronic Siren Project 28, from the 60in1 kit. But there's two versions of the 60in1 kit. There's the 28256 and there's the 28261. So actually the 60in1 got republished and things got reworked, but the Project 28 in the original kit is basically the same, except it uses the reed switch instead of just a manual switch. And the electronic Siren here, the component values all change because the power supply has gone up to 3 volts, where it's 1 volt in the previous. So and then down the bottom here is the link to his JS circuit if you're interested. So that might just be a bit more easy for you to read. You can just click on the image if you want to open it, and you can zoom in and such if that's what you want to do. So let's jump over to the booth together. Actually, we'll do it on the bench. Jump over to the bench and we'll assemble this circuit on our on our project lab. We'll just make this modification. So let's pop over to the bench and do that. All right, here we are on the bench. Now we're going to want to power this thing. So let's do that. What do we need? Alligator clips. Just give me 1 second. All right, so I've got the power supply all set up. We'll send the positive voltage in there and the negative voltage there. Now it's not turned on at the moment. Now what we're going to do, let me just get a copy of that schematic. All right, I'm going to wing it. So what we're going to do is we're going to put the 100k resistor in the place of the 470k resistor. So this will do that, and then we want the 470k resistor across the 10 microfarad capacitor. So we just need 2 white cables, which we've got. So we'll just connect the 470k across the capacitor. This will discharge the capacitor, and it should help us have an oscillating tone when we press and depress the button. All right. So we're going to throw the power on. All right. And we're not hearing anything. There it goes. Ripper. I'm actually, okay. Well, that's all well and good, but let's try switching it around so that the 470k resistor is at the top and the 100k resistor is across the capacitor. That might give us a shorter decharge cycle. And the tone might oscillate more quickly. I'm not sure how the top one will affect things. Let's try that and see how we go. So we turn him on and on. He doesn't want to play. Interesting. Well, there you go. So those component values can't be changed, as I assumed that they would be able to be changed. Curiouser and curiouser. All right. Well, yeah, that's really just not starting, is it? Okay. Well, let's turn the power off and let's put him back, see if he's just functional as he was. We haven't completely ruined everything. Put that in there. And that in there. All right, so that should be working as it was. There it goes. All right, so let's use our decade box. So we're going to want a resistance. Will that come right off? I'm not sure if that'll come right off. It doesn't matter. We'll use the banana plugs. Very good. So we'll use, what are we going to ug? How about green and gold? Good old green and gold. So let's plug the resistance in there and there. Now this will be in place of the 40k ohm resistor. So we're just going to take him out and hook this across the, oh no, that's not what we wanted. All right. Okay, give me a second, I'll be back. All right, I found some cables that will actually work, these. So let's pop in our banana plugs. All well and good. And then we're going to hook in our resistor across the 10 microfarad resistor. Now, if we put this in 470 volts, so let's say, just 1 second. All right, so I've got the resistor here set at 400k plus 40k plus 30k, 470k, and it's hooked on here. So when we power it on and we press the button, it should start to oscillate, which you might be able to hear through the headphone on the microphone. We'll see how this works after we pre-process everything. Anyway, that's the 470k. So what we're going to try doing is let's drop it down to just 300k. So 300k, let's turn that on and see what happens. And press him. Yeah, the tone adjusts faster at 300k. Okay. So let's try 200k. Okay, on we go. Press the button. Yeah, there we go. It dies out really quickly at 200k, doesn't it? So let's try 200 and 50k. So 250, 250. Okay, that's 250. We'll turn him on. Oh, so press down here. Yeah, okay. It does taper off a bit quicker with the lower valued resistor. I wonder if we can drop it down to something that's very close to 100k. Let's say 110k. 110k, and let's see if it works at all in that situation. Yeah, it does. It's just you have to hold the key down for quite a while to get enough charge through the system. There you go. So 100k is just about as small as we can go. If we put that down to 100k, oh, there we go. You have to hold the button down for a long time before it's there it goes. Okay, so the charge is very slow when the bottom resistor is low. Interesting. So I'm going to turn that off there. Yes, that concludes the the modification for our circuit number 1. I might just release that video today. This is our video for today, and next week we'll pick up with the second project from the 30in1. So it took a little bit longer to get through everything today. So yeah, let's wrap up. I'll throw the farewell cam. We'll wrap up.
And that's a wrap. So I thought I might close things off there. So today turned out not to be Project 2 at all, but instead some modifications to Project 1, thanks to our mate, Jason Jacques. So yeah, check out his channel. He's got a few recent videos, seems to be plodding away, which is great. So thanks very much, Jason, for getting in touch. Really appreciate that. Thank you for sending your suggestions through. I encourage everyone to go and have a look at them. And we'll pick up where we left off next week with Project 2 from 30in1 Maxitronix Project Lab. I hope you enjoyed this video. Thanks very much for watching, and please remember to click like and subscribe.